So let's dive into introduction to database services in AWS. So managed relational database using Amazon relational database servers or RDS, including Amazon Aurora. Managed NoSQL databases, including Amazon DynamoDB. So let's try to understand the AWS managed databases. So databases are the foundation of modern application development with two primary types, relational and non-relational. So there are 9 primary categories of database available on AWS, each optimized to support a specified type of workloads. So matching an application with the appropriate database type is essential for highly performant and cost-effective operation. So operational applications or OLTP are centered around regular, repeatable business process, while analytical applications or OLAP are run on demand for things like business intelligence workloads and data analysis. Databases power 21st century applications, and the efficient use of resources in the cloud requires organizations to be agile, responsive to change, and consider the requirements of scalability and elasticity. That's a glimpse into the world of AWS managed databases. So let's dive into the world of relational databases. Relational databases have been around since 1970s, providing an efficient, intuitive, and flexible way to store and report on highly structured data. The structures, called schemas, are defined before any data can be entered into the database. So data in a relational database is stored in tables, with each table containing one or more rows of data. These tables have primary keys that uniquely identify the information stored in each row. Data integrity is of a particular concern in a relational database, with constraints ensuring the reliability and accuracy of the data. The standard user and application programming interface of relational databases is the structured query language SQL. It is used to create, update, and maintain the data inside a relational database. Scaling an application. Relational databases are ideal for applications that do online transaction processing, such as online banking, e commerce sites, and financial services. However, for analytical applications processing larger volumes of data, non relational databases, also known as NoSQL databases, are helpful. Relational databases offers a structured and reliable way to store and manage data, making them essential for a wide range of applications. So let's dive into the world of non-relational schema-less and horizontally scaled data stores and NoSQL databases. NoSQL databases are a family of non-relational databases that includes key value databases, column family stores, document stores, and graph stores. They are also known for their flexibility and unstructured, rapidly changing data. The scaling a NoSQL database is easier and less expensive than scaling a relational database. NoSQL databases generally trade consistency for performance and scalability, making them a popular choice for developers. In summary, NoSQL database offers a dynamic approach to organize data, making them a great fit for applications with unstructured or semi-structured data. Whether it's a key value, document, or graph stores, NoSQL databases provides a wide range of options for developers. Amazon Relational Database Service (RDS). Amazon RDS, a managed service that simplifies the provisioning and scaling of relational databases within AWS. Amazon RDS offers a variety of database engine options, including MySQL, MariaDB, PostgreSQL, Amazon Aurora, Oracle, and SQL Server. Each engine is tailored to specific use cases and performances, providing flexibility and choice for your database needs. With Amazon RDS, you can streamline your database operations, and focus on innovation. Stay tuned for more insights on optimizing your AWS environments. Amazon DynamoDB, a fully managed serverless NoSQL database service. Amazon DynamoDB is a fully managed, meaning AWS handles infrastructure provisioning and maintenance. No database administration, server provisioning, or backup complexity required. It, it's also serverless, so server administration is invisible to the user. AWS takes care of the servers, allowing you to focus solely on your data and its modeling. DynamoDB is a NoSQL database storing data differently than relational databases. It supports key value and document access patterns, providing highly partitionable and scalable key value stores. So experience the ease and power of Amazon DynamoDB for efficient data management and access. Let's dive into the key features and characteristics of DynamoDB. DynamoDB is designed to be highly available by default, with data automatically replicated across three different availability zones within a geographic region. These ensures resiliency in the case of an outage or incident. DynamoDB provides fast performance and has no upper limit to how large a table can scale to, making it ideal for OLTP workloads that need high scalability and data durability. The database supports transactions and offers global tables for even greater level of resiliency and performance, enabling data replications across regions for low latency reads and writes. DynamoDB offers backup functionality, including on-demand backup and point-in-time recovery, ensuring compliance, and the ability to roll back to a previous state. DynamoDB is best suited for OLTP workloads, especially for new serverless applications, and is commonly used in gaming, e-commerce, and transportation industries. If you require a fully managed OLTP database that is infinitely scaled and serverless, DynamoDB is a great choice. So let's try compare the DynamoDB to relational databases. Relational databases scale vertically while DynamoDB scales horizontally, allowing it to scale almost infinitely. This means that DynamoDB scales transparently to the user, handling scalability without the need for manual management. Unlike relational databases with fixed schemas, DynamoDB is schemaless. This means you don't have to define a fixed table structure in advance, allowing more flexibility in adjusting columns and data types on the fly. While DynamoDB offers scalability and flexibility, it has limitations. For instance, its query and scan feature aren't as flexible as SQL, and it has a limited range of data types compared to relational databases. So if you're familiar with NoSQL databases like MongoDB, you find the DynamoDB varies in terms of data modes, models, and platform compatibility. DynamoDB has a strict limitation such as maximum item size of 400 kilobytes, which may require storing large objects in a separate storage solution. Consider these factors when deciding between DynamoDB and relational databases. So let's check out Amazon Neptune, the fast, reliable, secure, and a fully managed graph database service. Amazon Neptune is ideal for various use cases such as social networking, fraud detection, and recommendation engines. It's a powerful asset for understanding and querying complex relationships within vast interconnected datasets. Amazon Neptune uses its own graph database engine and supports two graph query frameworks, Apache Tinkerpop, Kremlin, and World Wide Web Consortium SPARQL. Additionally, a Neptune database cluster is comprised of single or multiple database instances across different availability zones, ensuring high durability and reliability of data. Neptune storage auto repair automatically detects and repairs segment failures, minimizing data loss. Replica instances are used to scale read operations and provide failover support, ensuring minimal lag for read query results. Amazon Neptune provides three types of endpoints: cluster endpoint, reader endpoint, and instance endpoint, each serving different purpose for accessing the database. Now that you have a better understanding of Amazon Neptune, you can explore its capabilities and consider its potential applications in your solutions. Amazon Memory DB for Redis, a fully managed in-memory data store service that's compatible with the popular open source Redis data structures too. Amazon Memory DB for Redis is designed to provide ultra-fast, low-latency access to data stored in memory, offering microsecond read and single-digit millisecond write latencies. It gets deployed as a cluster within your VPC, with each cluster consisting of one or more nodes responsible for serving a single dataset. These nodes are partitioned into shards, each with a primary node and up to 5 read replica nodes spread across availability zones to provide high availability. In addition to these features, MemoryDB for Ready supports clusters up to 500 nodes in size, transaction logs distributed across multiple availability zones, data tiering, encryption of data in transit and at rest, and snapshots for easy backup and restore of your MemoryDB cluster. In summary, Amazon MemoryDB for Redis offers ultra-fast access to in-memory data sets and can help you reduce the complexity and cost of managing data store infrastructure for your application.